Who pays the $85 a ton?
That's a tax credit, so that comes straight back from the feds. How that actually works kind of depends on the entity. My understanding is that because Basin Electric is essentially a nonprofit co-op, that they get a straight cash back as opposed to a tax credit, which in theory, again, I'm not a tax attorney, but my understanding is with like the credit that would come against like your actual profit. So if you didn't have enough tax liability, you may not realize the full tax credit. You know, same thing with like an individual tax credit if you put in, you know, I don't know, some feature and you didn't have enough taxes. But in the case of Basin, they just get the full $85. So no credit offset required on that.
Out of curiosity, it might not be a question for you, but the flue gas, I know we removed the ash, we removed the sulfur, now we're removing CO2. What's left? What's in flue gas, I think?
Yeah, I mean, you're still going to see a little bit of emission stuff coming out, but for the most part, it's going to be down to nitrogen and argon.
That's good.
I mean, and some water still coming out of the stack as well. You know, I mean, if you were to take a look at the flue gas now, you know, there's still small amounts of sulfur that come out, much less than if you just burned the coal straight, and much less than if you burned other coal, because this coal is actually pretty low sulfur coming out of the Powder River Basin, as opposed to say like Illinois number 6 or, you know, some other higher sulfur content coals that you might start with. There's still going to be a little bit of mercury and some other stuff.
But you've answered my question.
Yeah. Any other questions?
So with the carbon capture, we're hoping to extend the life of coal plants. Is that it? And other?
Yeah, I mean, I think so. I mean, I think there's a lot of ways to look at it, but certainly it extends the viability of a variety of fossil fuels. But I think it also, you know, if you're looking at it from more of the environmental perspective, it gives you a way to, you know, slowly ramp up some of the other things, you know, some renewables and some other options, as opposed to trying to like flip the switch in one day, which is, you know, not practical. We still need energy.
There are also a ton of industrial sources that are classified as hard to decarbonize, and so they're not going to switch over to electric so much as easy. This technology could work on that kind of for those industrial sources in the future.
Right. Yeah. So while we're testing this at Dry Fork, which is a coal-fired power plant, other types of things could benefit from this too. Could be a, you know, steel processing, blast furnaces, smelters, concrete manufacturing is a good example. Even if you tried to convert everything to electricity, concrete manufacturing reduces carbon dioxide. So, you know, there are some places where even in a quote ideal world where you never needed any more fossil fuels ever again, we probably want concrete because it's pretty good. So,
You mentioned, I think, in the commercial scale that there'd be some steam usage for this technology. In this pilot scale, I imagine a full commercial scale, you'd be pulling steam out of the process for a commercial plant, but in this pilot scale, you're using plant generated steam, you got to generate your own steam.
So for this, and actually for most of the things that we're looking at from a retrofit standpoint, what we find is that a lot of potential customers, they really don't want to give you steam. I mean, there's a lot of these sorts of technologies like to use steam. If you're looking at like the liquid amine type towers, they go through a reboiler process, and they like to use the thermal energy from the steam to kind of heat that solution back up and release the CO2 on that. But what we find when we talk to various people, you know, they want their steam and they want to use it to generate electricity or, you know, what have you. They want a really clean retrofit where you could just stick it next to the plant, deal with the gas that's kind of coming out as it is. So we generally are looking at making our own steam. But we actually do most of that from water that we're taking out of the flue gas. So the flue gas that's coming in the case of Dry Fork, is hotter than we want it. So we're going to knock some of that temperature out. That's going to condense a bunch of liquid. And then we're looking at what we think are clever ways of basically taking other heats in the system and reutilizing them in part of the vacuum process to generate steam as cost effectively as we can, but then we use that in the process. So once the process gets going, it's about neutral on water, depending on exactly the flue gas temperature and composition. You know, it might make a little bit of water that you could send back to the plant treatment, or it might use a tiny bit, but it's pretty close to zero net.
I mean, the reason I was asking, I can't quite get, I don't know, 1.5 mole for whatever you want. Like, you know, what kind of steam demand that really is, you know, or how much, like a megawatt equivalent or something like that, would that be?
Mhm.
Or, I don't know, tons of CO2 equivalent or something that,
Yeah, I mean, from a power consumption standpoint, it's a decent chunk of the power that we use, but actually the vacuum generation is the biggest chunk. That's where we use most of our power.
I mean, I've seen some of the other ones that are looking at like 30% of the plant load. It's like a parasitic load to run one of these plants. Is this one on that same scale of energy input?
I mean, you're looking in that kind of a ballpark. So if you were looking at a new manufacturer, essentially building a whole new coal plant, you know, you might be in that, you know, somewhere between like 20 and 30% overage in terms of the amount of coal that you're burning and the BTUs that the plant is generating relative to the power generation. Once you take that off the top, you know, that's a pretty standard kind of thing.
Is that quite a bit less than direct air capture? Like, does that, like if you're taking CO2 out of direct air, it probably takes a lot more energy.
Yeah, so in general, the easiest way to think of this is the higher the concentration of CO2 is where you're pulling it from, the easier it is to grab that CO2. I mean, and you can think of like if you had a jar of marbles and, you know, 1 out of every 10 of them was blue and the others were, you know, red, pulling the blue ones out wouldn't be that bad. If you had a jar of marbles and 1 out of every like million is blue or versus red, it's a lot harder to find. And that's exactly the case with like that direct air capture. You're pulling out about 400 parts per million CO2 versus at dry fork, it's more like 12.5%. In some cases, it can be even higher. Things like ethanol plants can be really high. So that had a huge impact on the cost. And that's one of the reasons why the credit value for like direct air capture is higher as well too.
But on that note, we also are developing direct air capture technologies. So if you're curious about that, if you check out our community benefits website, there's information on those projects as well.
So on the question of profitability, what is the assumption right now you're working on that how far out in the future will your company or the company that ends up with this technology be able to build a unit and sell it for a profit? How many years down the road is that?
Well, like I said, we're hopeful that we'll be able to actually deploy this unit at the end of the test of a commercial unit. So, you know, we would be looking at that in the, you know, like 6.5 year time frame or so. You know, if we're able to get somebody in the commercial market faster than that, that would be great. You know, one of the pros and cons of, you know, dealing with, you know, federal money is that you're also tied to their timeline, which is not necessarily as fast as you might want to go. But, you know, they're balancing their own risks too, of course, you know, they don't.
And why we might want to go faster is because even though CO2 capture is moving at a certain rate here, other markets like in Europe, for instance, it's moving a lot faster. And as an American company, we don't want to lose out on that entire market. I mean, there's plenty of CO2 capture to happen there too.
You said, do ethanol plants put out more CO2 than a power plant? Is that what you just?
Concentration wise, yeah, they're pretty high.
Yeah.
Yeah, they're pretty easy to clean up. In fact, in some cases, if the concentration gets high enough, like this isn't even, you know, you look at other alternatives because this, basically the concentration and the temperature, what you're doing with from a flue gas, that kind of drives what technology makes the most sense for that application. So there is really no one shoe fits all. Like we wouldn't use this material for a direct air capture project. It doesn't bind the CO2 tightly enough to pull it out of that low concentration stream. And we wouldn't use it for like an NGCC turbine either, which has maybe like 4 to 6%, depending on whether it has like gas recycle or if it's just straight burning. For that, we would use a different kind of material that can grab the CO2 a little bit more tightly and pull it out of that lower concentration stream, but takes a little bit more energy to regenerate, which is kind of the flip side of that. So one of the things that's really nice for this kind of an application in that, 10 to 14% kind of a range is that the mesoporous carbon doesn't hold on to the CO2 very tightly, which makes it kind of easy to regenerate, but it limits its usefulness in low concentration applications. So this is kind of a sweet spot for this particular sorter.
So I guess so are y'all doing any projects to try and capture the CO2 out of ethanol plants? Sounds like the ethanol plants are more polluting than a CO2 plant.
I'll skip on that part. We don't currently have an application for that, but we do have applications in NGCC turbines, cement, steel type applications. We are looking at, like Sarah said, direct CO2 capture from air as well. We have some interesting projects where we're looking at making things like methanol from CO2 capture from the air. So we take that CO2 and then run that through a methanolization plant as well, so we can make green methanol. And other people are looking at green hydrogen in similar kinds of ways. So I mean, those are all on the kind of technology radar.
Our nearest project converts the CO2 directly to carbon, which you could then sell like graphite or graphene, or you could just bury it in the ground. This is carbon.
That one's a pretty small scale so far.
Yeah.
Would that make more coal?
Yeah.
Yeah.
Cool.
It's kind of like a recycle.
You mentioned other things as the Department of Energy facilitating other technologies in the same way, and can we make any comment on some of those other technologies that they have demo plants going?
They do. I mean, I can't talk a lot about the other technologies in particular. Out of this particular funding round, so this came out of what's called the Bipartisan Infrastructure Law or the Bill Act. Some of the community benefits things are prescriptive from that specific legislative piece. That particular funding round within OSED, which is a newish agency within DOE that specifically does these kind of large demonstrations, has a total of 4 different demonstrations that are funded. I don't recall the names of all of them off the top of my head, but there's one in, I believe, Kentucky, one in Texas. I believe that there might be Illinois, but I'm not 100% sure on that. But they're all similar kind of scope in that they're looking at fairly large demonstrations in the kind of same range as what we're looking at, a couple 100,000 tons a year type area, looking at that. And the goal with all of them, I think, is to try to advance, different kinds of technologies to get them closer to that commercial threshold so that there's more options when a plant or a company decides that they want to try to deploy, so that there are multiple options to choose from.
So in the workforce, do you have it identified how big a workforce you're going to need for the construction of the demo plant? What skills?
Right, what we have right now is an estimate where they're saying about 40 people to construct and 20 to operate, but that is completely like back of the envelope estimate. So by the end of the phase 1, the engineers should have a better kind of outlay of what that looks like, how many people and what kind of jobs those will entail. And we'll report that on the website when we get that information.
But what I will say is it's going to be a lot of the same kind of jobs that you would expect for a lot of the stuff that's going on in Gillette already within like coal, natural gas, oil, and these kind of things. So, we'll have to do a lot of earthworks. There'll be, concrete work. There'll be fabrication work and steel for vessel design, electrical for sure, plumbing, pipe fitting, a lot of those things will definitely be part of the picture. Where it gets kind of interesting is when you get into sort of like the plant operations, where, plant operations for a carbon capture facility is kind of a new concept. It's mostly been in these small demo scales so far, but eventually you'll need operators. But we think there'll be a lot of overlap with existing, like chemical engineering plant and or power generation type facility operators. So similar skill sets, if not exactly the same. Yeah.
You mentioned that there was some go, no-go steps along the way. Can you give us some examples of what would create a no-go situation? Any of those?
ultimately, I guess that's really up to the DOE as much as anything. But I would say the biggest ones would be us failing to hit some of the technical objectives. So if the feed design doesn't come in looking at the cost that we thought that it was going to be coming in at, that could be a potential issue. If we're, starting to take a look at a deeper dive into permitting or regulations, and we find that for some reason, like the host site isn't going to be able to accommodate that. That's very unlikely in this particular case because there's already about a 10 megawatt demo going on at the host site. So, we've tried to clear most of the serious issues ahead of time. Financials could certainly be one of those. In addition to the project partnership team being responsible for about 30% of the overall cost, we're responsible for 100% of the contingency.